Hello everyone, I'm Otto, and
Vivi.
today we are going to explain about the concept of equatorial coordinate system and part of celestial objects in one-line observation by using the magical sphere that we built. Unlike horizontal coordinate system, equatorial coordinates are independent of the observer's location and also the time of the observation. The small sphere at the center is the Earth. The celestial equator is the projection of Earth's equator onto the celestial sphere, and the part that Sun generally follows on the celestial sphere is called the ecliptic. It is tilted by approximately 23.5 degrees relative to the celestial equator. The intersection of ecliptic and celestial equator has 2 points. The one that Sun is moving northward is the vernal equinox around March 21, and the southward is autumnal equinox around September 22. The Sun reaches its northernmost point at the summer solstice around June 21, and the southernmost point at the winter solstice around December 21. Next, what about the daytime, nighttime, and how does the Sun rise and set in each season? So, for the vernal equinox and autumnal equinox, the Sun is positioned directly above the Earth's equator, resulting in nearly equal daytime and nighttime durations worldwide. And this completely different for the summer and winter solstice. Let's go for the summer solstice first. We'll focus on the location on the northern hemisphere first. As you can see, the northern hemisphere has more area that's exposed to sunlight than the shaded area, so the daytime is longest and the nighttime is shortest. Similarly, in the winter solstice, as it's named winter, the daytime is shortest and the nighttime is longest. However, this thing is opposite for the location on the southern hemisphere. For the vernal and autumnal equinox, the Sun rises due exactly the east and sets due exactly the west. But for the summer solstice, the Sun rises as far to the northeast as it ever does and sets as far to the northwest. On the other hand, for the winter solstice, the Sun rises as far to the southeast as it ever does and sets as far to the southwest. In the equatorial coordinate system, the reference point is the vernal equinox, where the celestial equator intersects the ecliptic, and the reference plane is the celestial equator. Declination is the angular distance of a celestial object north or south of the celestial equator, ranging from -90 to 90 degrees. On the other hand, right ascension is the angular distance measured eastward along the celestial equator from the vernal equinox, expressed in hours, minutes, and seconds, or even the degrees, ranging from 0 hours 0 degrees to the 24 hours 360 degrees.
So let's talk about the identifying of declination from horizontal coordinate system. These are the example of star A and star B. So as we can see from the left, this is the celestial coordinate system, and from the right, this is the horizontal coordinate system. So the first example is about the declination of star A. We assumed observer at Thailand 15 degrees north of the latitude. So the NCP is upper from the horizon equal to the latitude. And let's focus on the declination. Declination is from NCP to celestial equator, and this is exactly this line. And we can see the star path is here, so it's upper from CE as the degree of declination. So this is the star path we see from the horizontal system. So when we observe, we see the star pass our meridian at the altitude as observed. So from this diagram, we can see the altitude to the celestial equator, which is altitude plus declination. is equal to 90 degrees plus the latitude. And this is the equation looks like. So next, move to example 2 of star B. We can see the declination is higher than star A, and also the latitude we assume to 60 degrees north. So NCP is higher than before, and use the same equation, we can find the declination if we calculate from the altitude and also the latitude. But the uniqueness of this example 2 is you can see the star path here, which is the same as that line. They're above the horizon, and which means it is a circumpolar star that won't fall, so we can see them like all night long. So the property of circumpolar star is when 90 degrees minus the declination is less than the latitude of the observer, so that we can identify the circumpolar star. Thank you.